know why we have scientific notation? What's its purpose? That's exactly right. It helps us deal with very, very large numbers. I was just talking with my kids and my husband this weekend. We were at the Museum of Science and Industry in Chicago, and we were talking about the speed of light because, well, something was traveling very close to the speed of light, and we were looking at a Tesla coil. We had one of those at the Museum of Science and Industry, and they were discussing the speed of light. And so we're talking about it's 3 times 10 to the 8th power meters per second. And that's scientific notation. So instead of saying 300, holy cow, let's hope I can do this. Yeah, I said it to him, so let's hope I can do it now. So it's 3 with 8 zeros after it. That's 3 times 10 to the 8th. So 3 with 8 zeros after it would be 300 million meters per second. And then he was asking, well, how many miles per hour is that? How many miles per second? And then I got my calculator because I can't do that stuff in my head. But scientific notation helps us to not have to say things like 300 million. We could just say 3 times 10 to the 8th power, which means 300 million meters in 1 second. That's how fast light travels. What else does scientific notation help us describe? Besides very large numbers. Very small numbers, exactly, like the size of an atom, okay? To describe the size of an atom, like how many centimeters the size of an atom, you'd have to say 0.0000, just keep going and going. And no one keeps track of that, you just lose track of the zeros. And they're very important. So that's where scientific notation comes in. So the way scientific notation works is it's all in terms of 10 to a power. And that initial number is between 1 and it's less than 10. So the number that goes here is a single digit, a number between 1 and 9.9. So that is the form of scientific notation. And these are rules for converting a number to scientific notation. The exponent is the number of decimal places that you have to move to get the number into scientific notation. So to find the exponent, that's just really counting. And the way I think of it is you move right. If you have a positive exponent, if the number is big, you're going to have a positive exponent. Like 3 times 10 to the 8th, 8 is a positive number. So that's going to be a very large number, like the speed of light is very fast. Whereas very small numbers, you have a negative exponent. And I'm trying to think of a small, like chemistry or physics number that I have memorized. I don't have any off the top of my head right now, but yeah, I should have known like the size of an atom. That would have been a good one. But if you have a negative exponent, that's for very small numbers, like 0.000. You're going to have a negative exponent in scientific notation. So I just remember small negative exponent, large positive exponent. So that's really helpful in converting to standard notation. So standard notation is just how we regularly write our numbers. Scientific notation is how we write our numbers in physics class, chemistry class, sometimes math class, and biology class. And the difference between scientific notation and finance is in finance we say millions, billions, and trillions. But in science, we say times 10 to the 6th, times 10 to the 9th, times 10 to the 12th. Yeah, there was just a game show that said, if you have a 1 with 12 zeros, what would you call that? And the guy couldn't come up with trillion, and he lost $1 million. He couldn't come up with that. I was very thankful that I could come up with that answer. But if you know scientific notation, you don't have to know that because you just say times 10 to the 12th. So it's just interesting. So yeah, let's do this because I don't know, reading steps sometimes is not as useful as practicing. So if I were to convert this is all scientific notation. This is what it looks like. So you have a decimal quantity that is somewhere between 1 and less than 10. So these are these quantities in front, and it's times 10 to a power. And they always use the X for times, just like elementary school. That's just the convention. They don't use the dot because the dot is used in the decimal. So they use the X for that. So to convert this from scientific notation to just regular numbers, this tells you you're going to move the decimal 6 places, and because it's positive, a positive 6, you're going to move it to the right. So what I do is I write out RWIT. I write out 7.02, and then I move the decimal 6 places to the right, and it's to the right because 6 is positive. So 1, 2, 3, 4, 5, 6. So that is now where my decimal is. And what do I fill in those missing spots? Right? Zeros. So this is actually 702,000. So it's actually 7,020,000. That is what the number is in just standard notation. You know, how we read numbers without scientific notation. Are you okay, or did something? Did it keep it in scientific notation by any chance? Did it have a small e there? So in your calculator, the way it does scientific notation is it uses a small e. Did it say 06 or just 6, Brendan?
Oh, this is the next one. I added it and it makes 113 e -5. Yes, and then it showed up as the same thing.
It showed up as the same thing. Yeah, so the calculator, when it finds you have too many digits that it wants to handle, because there's only so much horizontal space on the screen, it just tells you the answer in scientific notation. So in scientific notation, the calculator gives you E, and the E stands for exponent. So this means 7.02 times 10 to the 6. This is how the calculator writes scientific notation. So that's the calculator's version of scientific notation. So it's not extra helpful always for going back and forth. So for this one, the 5 is negative, so you're going to move left for this one. 5 digits. So I'm going to write down the 8.13. And now I'm going to move the decimal left 5. So 1, 2, 3, 4, 5. I misjudged with my equals there. So there's the new location of my decimal, and I'll fill in zeros. So my new number is 0.000813. Now some teachers are super picky and they like to have a lead zero, like 0.000813. I don't really care. It's just you have to have the decimal. Here you don't have to have the decimal because it's implied. But if it's a small number, you need to have the decimal here or else those zeros make no sense. So that's a very small number. Negative exponent, small number. Positive exponent, big number. Positive exponent, the amount of money I'd like to have. Negative exponent, who cares? All right, this wouldn't even register in my view. So another way to look at it. So if we were wanting to write a large number in scientific notation, like 7,346,200, this is the step-by-step process. First, we write it as a single-digit decimal. So you're going to throw the decimal right after the first digit. So our first digit is 7. You throw the decimal right after the 7 to make it 7.3462. Then you need to ask yourself the question. I should move this up so it's less overwhelming here. Then you have to ask yourself, how far did you move the decimal? Okay. Well, the decimal started back here. It was invisible, so that means it was at the end. And then I moved it 1, 2, 3, 4, 5, 6 spots to get it up there. So I moved it 6 spots. So that means my exponent is going to be either 6 or positive 6 or negative 6. And then is the number large or small? Let me move that. If it's large, the exponent is positive. If it's small, the exponent is negative. So large numbers, you get a positive exponent. Small numbers, you get a negative exponent. So this is 7.3462 times 10 to the 6th power. It's positive because it's a large number. It's 6 because you move the decimal 6 places to get it in the spot it needs to be. Because remember, this number right here has to be between 1 and less than 10. So that means you have to put the decimal right between the first, the lead digit, and then the second digit. So it's somewhere between 1 and less than 10. All right, questions on that? So let's write this in scientific notation. Who can tell me what the number in front would be? Amelia? 3.48. Good. Brendan, how far did I have to move the decimal to get it between the 3 and the 4? How many spots?
Twice.
So here's 1, 2. Am I there yet?
Or sorry,
3 times. Good. So times 10. And is it a small number or big number, everybody? So it's negative 3. Okay? So I moved it 3 times, but because it's a small number, it's negative 3. If it were a big number, it would be positive 3. Questions? Okay. Now, you can do some mental math with scientific notation because we learned how to add or multiply exponentials. Okay. This is just 6, right? 3 times 2 is 6. What's 10 to the 6th times 10 to the 8th? Isabel? Yeah. 6 times 10 to the 14th. Is that number in scientific notation? It is. You just have to check to make sure that this lead number is still legitimate. It's still between 1 and less than 10. Because it can't, if this number were like 60, I would have to adjust. Okay? But this number is okay. It's still between 1 and 10. But you can use what we've learned to multiply those without a calculator. So that's why they throw it in this section. Yes?
If it was 60, you would do 6.0, but then what would you do to the exponent? How would you change that?
You would have to adjust it. Okay. I think this next example is going to help us with that. Okay. So here we have 4 divided by 8, and we're going to write that as a decimal because we don't really use fractions in scientific notation. So we know 4/8 is a half, and we know 1/2 is 0.5. Times 10, what is this part going to be? 10 to the what? So you're subtracting the exponents. So 5 minus negative 2 times 10 to the 7th. Is that incorrect scientific notation? No, it's not, because this number is too small. So that's what I was talking about. You have to adjust this power then. So this is tricky, all right? For 5, I have to multiply this by 10 to get it to be big enough, because it's too small right now. Okay. So I have to multiply it by 10 so it's big enough. Okay, in other words, I have to move the decimal 1 to the right to get it to be big enough. Now, if I multiply this by 5, yes, DJ?
Would you have to
Or by
multiply the percentage?
Well, if you multiply a number by 10 and you want to keep the number the same, what do you then have to do to it right away? Like if I take your age and I multiply it by 10, and I want to get it back to your original age. Yeah, so if I multiply by 10, I have to divide by 10. I'll write it like this, divide by 10. So if this part I multiply by 10 to make it follow the rules, here, to make it balance, I have to divide by 10, so it's the same number that I started with. So what's 10 to the 7th divided by 10 to the 1st? What? Yeah. So this one got 10 times as bigger, and to keep it the same, I had to make this 10 times smaller, because it's the same number. Okay, it's like I borrowed $10 from you and then I had to give it back. It's one transaction, so I have to keep it equal. So within the same number, if I multiply by 10, I have to divide by 10 to keep it balanced. So this is the trickiest thing we'll do with scientific notation, but you have to balance it. That's why you have to divide by 10 and then multiply by 10 to keep it in scientific. That's tricky. Okay, so there is your assignment. You can only check the odds. We will check the evens and pass those tomorrow.